Alright, let's try this one more time. Apparently my stream key has changed. And here we go. There I am. At least in the web browser, which I can't watch because the delay is pretty funny. Alright, so we blame YouTube on this one. I don't know why. I'll have to make notes of checking the stream key before I get started. So we will get take 3. So good morning or appropriate salutations for your time zone. My name is Mark, KA6WKE, and welcome to Bench Therapy, another supposedly relaxing hour and a half or so at the bench. We're slowly getting things figured out here. I checked everything last night, and of course, when I start the stream here this morning, things have changed. So welcome to Windows, welcome to YouTube. Thank you very much for keeping everything organized for me. I don't need any help looking like an idiot. Anyways, let's talk about some of the projects I have going. Well, the first thing is the studio. I've made some improvements, well, a lot of improvements since the last time. You can see me now, which is something I thought back and forth for a while of whether I should do or not. Hold on one second. It's not showing up on my tablet just yet. The live stream, maybe on my phone. No, still showing offline on my phone, but it's showing in the web browser, and we'll go with that. So updated the studio. You can see me now. Something I thought long and hard about to do. I thought I'd just be the mysterious set of hands, working under a scope or under a camera. Got that taken care of. Better lighting. You can kind of see a little bit of too much light here on my right. Trying to figure things out here, but it makes a huge difference in the video quality. So I did that. Let's see. I've added a top camera, which is right there, and this went through quite a few. I had to buy quite a few to get a nice one that's not $1,200, since I make no money from doing this. This is all just for fun. I got that figured out, which is nice because this camera has an optical zoom instead of the digital zoom that I was trying to use webcams with. So I gave up on that. Webcams very well for doing this type of work. And I guess I just had to learn the hard way. So I decided to put the retired webcam into use here, so you can see me in the intros and things. So with that said, let's get to work on project status. So the project's, the desktop kilowatt is still in play. I'm collecting the tank circuit parts that I had about 1.5 years ago, and I sold them all because I never thought I'd be building an amplifier. And lo and behold, I am. So, well, they are actually quite difficult to find. I've been searching high and low. I did manage to get some. Coil stock, 3-inch coil stock, about 1 foot long, so I can so hold on, let me make a quick adjustment here. There we go. Yeah, that'll be better. So I got some 3-inch coil stock. I got that from a local ham, actually, and now I need that switch to switch bands 80, through hopefully 160 through 10 band switch, heavy duty switch, which I had in my stockpile way back, about 18 months ago, but sold it. The other option I'm thinking of going with is just with a roller inductor, which I also had one and sold, to use that instead. That does make it a little bit easier because I don't need to have a band switch. I don't need to go through and figure out the taps on the coil to, match the tube impedance to the, to the output impedance of 50 ohms. So that would be nice, nice to have. And I'm sure I could find one. Some usually pop up on QRZ or something like that. So the N2PK, the Vector Network Analyzer, I got the case for it. I need to finish designing the little internal power supply for 12 volts and 5 volts DC, which will be a linear supply. No switching in this one because from what I've read, it's this Vector Network Analyzer is rather sensitive to noise. So I'll get that done. I got the case, a nice black case, so I can get things laid out, the front panel laid out, and put that together. And that should be pretty straightforward. Another segment I've decided to include is what I found on the internet. So part of kit building and home brewing is having resources to help you build things. And one of this YouTube video, that's what it's for. This live stream's about. It's about showing you how to build things from start to finish and go over the basic discussions of how the circuit's working and things like that. And as I've said in my previous videos, you don't need to fully understand how the schematic works or how the individual components work. You just need to understand signal flow, power flow, things like that, so you can get an idea in your head of how the circuit as one piece, as a system, is working. So you don't need to get too heavy into electronics theory and things like that if you don't want to. If you do, there are plenty of resources on learning electronics on your own. And one of the home brewing places I found on the internet is K7QO, Kilo 7 Quebec Oscar. He's got what's called a lab notebook PDF, and it's full of ideas on how to build just about any type of electronics, from making your own circuit boards, making your own chassis out of circuit board material, which is things that I've tried to do and wasn't very good at, but after I didn't have any good results with it, I read on his technique, and it's like, oh, that's why all my corners were crooked and things like this. So Kilo 7 Quebec Oscar lab notebook, put it in your favorite search engine and you'll find it. It's like 450 pages long and full of great ideas to help you in your building. So only one page of notes this morning, and we're done with that. Let's get started. Also, you may know, since I'm a 6 land call, which is correct, I do live in the Southern California area. Everybody in my family is asking me, have you been feeling the earthquakes on Ridgecrest? And I have not. My wife and I have not felt anything, actually. Although some of our friends from around San Diego County says they felt it. My in-laws that live in Las Vegas, they have felt it much stronger than we have. Okay, so with that said, let's get started on our project here. So what I want to do with building projects here is starting from how I receive it in the mail. So today we're going to build QRPGuys digital field strength meter. It was reviewed in the May QST. May QST, I think it was pages 58 and 59, if I remember correctly. And I thought it'd be a great kit here to build for this episode of Bench Therapy, because it's a nice combination of, well, it's got one surface mount part, the AD8307 logarithmic detector amplifier, which is the heart of this. And I'll go over 2 different techniques on how to solder this down for this project. Let's see. So I wanted to start with the project as I receive them. What I do is, actually last week I opened the package and did the inventory of all the parts. I wanted to make sure that they were all here before the live stream, and happy to announce they were all there. I actually got some extra parts, an extra capacitor and an extra 9-volt battery clip. So the QRPGuys want it back. I'll drop it in the mail. So anyways, this is the way I received it. It's packaged well, actually. You know, standard package, bubble wrapped and all that, and everything is put into one little Ziploc baggie here. Prior to the show, I took out the circuit board and I cleaned it. And as in my previous videos, how I clean my boards are I use warm water, some of the old school blue Dawn detergent to get all the grease and anything left over from manufacturing on it. And then once I towel it dry with the paper towel, and then I take some 100% isopropyl alcohol and wipe everything off after that to get any remaining soap residue and things like that. It's very important to have a very clean, as clean as possible, circuit board so your solder joints come out looking good and they're solid. And then after that, don't touch it with your fingers, just, you know, hold it on the edge like so. Let's see what's in the bag here. So they give you a little antenna here to, it looks like a Wi-Fi type antenna, I guess it is, but really it's probably just a wire stuck in there for receiving the signal here. We've got, this is a digital voltmeter. That's part of the project. The digital voltmeter is right here, which will need some modification later on, and it's in the instructions. Let's see what else we got here. Foot stuff for the bottom. And the bottom of the board has circles where you put the little feet, and then the rest of the parts here. So we'll get things kind of sorted out. Unfortunately, yeah, we'll get things sorted out here. That's one of the inputs. Here's the battery. Clips for the 9-volt battery. Here's my extra clip, socket, and the op amp for it. I'll go in there later. Move the feet out of the way. Got our various resistors here. The second way to connect an antenna or test probes. Well, actually, this is more for an antenna. On-off switch, momentary on-off switch. Here's the logarithmic amplifier. It's not too bad to solder down, and like I said earlier, we'll go over some two different techniques to solder this down. We've got the remainder of, oops, wrong way. And then we got the remainder of the capacitors, resistors. We got some diodes thrown in here for good measure. Get these out of the way. Here's our capacitors, and this is one of the ones that I've got that are extra. This is little wires to be used as a jumper on the voltmeter to change its voltage divider. We got a little 78LO5 voltage regulator. Your LED, of course, got to have a little LED to know when it's on and off. Mounting screws for the voltmeter. We'll set those up here. This little red, it's hard to tell, but it's red lens to go over the voltmeter if you want it. Variable resistor for setting the sensitivity. And that's it. That's the rest of this kit. So everything's sort of organized here. I got the instructions up on the screen so we can go along with the project. But first we'll go over the schematic. Let me minimize my maximums, and all right. So let's go over the schematic here and how this works. So here it is. It's not much to it. It's rather straightforward, I think. Starting on the right side here, we have the 9-volt and our on-off switch. And I had mentioned that the little diode to indicate when the power is on. So this little 10K resistor here is for the voltage drop that's required to make the LED light without frying it, because 9 volts is too much. The 78L05 and its associated filter capacitor. So this is a 5-volt regulator, linear regulator. For this circuit, and we have then it goes off to two directions to power the what happened here? Oh, wrong one. Sorry about that. Got new software to draw in PDFs. So it goes in two different directions. One for our AD8307, the logarithmic amplifier, and then the other one comes down here to power the LM358. The data sheets I will put in the descriptions below, so you can get an idea of what the pins mean and the different what the pins are for, all the inputs and outputs, and so forth. So here's our variable resistor for sensitivity. This is the bad boy here that does all the heavy lifting to convert the RF that comes in from one of the two connectors into the chip to convert that to a voltage. That the LM358, I think it has a voltage divider for negative input here, and I think this is kind of a buffer and voltage amplifier for the voltmeter, so it can actually work at a reasonable amount of voltage, so it'll display. Let's see here. These two diodes here are these back-to-back diodes are used for protection. They if the input voltage exceeds their voltage values, their voltage ratings, they will clamp down and divert everything to ground, so that way you don't ruin your chip, your logarithmic amplifier here. And then this is just a blocking capacitor in case DC gets on the line somehow. You don't want to put that straight into your 8307. So that is the schematic. And so the signal comes in this way, in through pin 8, which is the input. It's actually a signal input plus polarity on this particular chip. Power comes in here to pin VPS, which is positive supply between 2.7 and 5.5 volts. EMB is the chip enable, so when the power turns on, it also turns the chip on. Pin 5 is not used. These two pins here, common of course is pin 2 is ground. Pin 1, we go over this as the signal input. INM signal input minus polarity. Now I'm not exactly sure what that's about offhand, but it just has a 0.1 microfarad capacitor to ground. You don't need to really know why it's designed this way. Just understand how things are flowing in the circuit. So once the chip's turned on and we have an RF signal coming in, it's going to give us an output of some voltage, and goes through the variable resistor into pin 3 of our op amp here. And it's a very common op amp. there's two in this chip actually. This one down here is just shut off essentially. You can't. It's not good design to leave op amp outputs floating. So you want to make sure everything is shut so the input is grounded and the output comes back into the negative side, which keeps everything at 0. If I'm understanding that correctly. So these two resistors here form a voltage divider and provides a little bit of feedback into the op amp. So there's to keep things stable, to keep the voltage instead of swinging up and down like crazy. It helps it stabilize. No, I'm sorry, I got that wrong. That's not the voltage divider. These two are the voltage dividers. There you go. So then we have the output comes here through the resistor. A little bit of this should be DC coming out of the op amp. If there's a little bit of RF on it, this little capacitor here will bypass that to ground, give you a nice clean voltage coming out of here, and then we put it into the voltmeter, and it'll display a voltage that reflects the signal strength coming into the chip. Okay, and that's what a voltage detector does. Now this is all relative. It's not a direct reading. You're not going to say, oh, it's 4.7 microvolts or something like that. It just gives you an idea of what's going on, and it'll give you an idea of relativity. So if the voltage doubles, I think it's 4 times, I don't remember the math off the top of my head, that the input signal strength increased 4 times or some number of times. So with that said, let's get started. We've got this. Let me zoom in a little bit more. Now let me zoom back out again. Okay. Let's get going with the logarithmic amplifier. So I'm going to be using a scope with this. You don't need a scope at all to work on this project. Matter of fact, you can. What did I do with it? Oh, it's right here. You can actually get away on this project using one of these little headphones, little headlamps. Sorry, magnifying with its little associated magnifying glass. And I used these for a lot of years, and it was fine. But as I got more into the live stream and working on parts that are even smaller than this, I went to a microscope. I'm using the scope today because of the quality of the video that I want, and so you can see what's going on. Let's see, and there we are. We're right here. Let me get things straightened out here. All right. So there's a couple of ways to solder this down. You don't need a hot air rework station to do that. You don't. You can actually do this by hand. And there are 2 ways. One is tack soldering, which I'll show first. Actually, I got to turn my soldering station on. Get the appropriate tools here. Get this out of here. All right, get out of there. I don't need to see you. And there we are. Our AD. A little hard to read with. On an angle is a little better. So pin 1 is where it is closest to the dot. Now there's 2 dots here, but it's in between pin 1 and 2, but pin 1 is right there. Pin 1's right there. Now there's two ways to solder this down. First one's the tack soldering, and I'll show you that in first. But a word about flux. So I watch other hams build things, or other people, not just hams, building things, and you know, you need pretty thin solder to work with it. To work with these components. I used to use paste, solder paste, because not only did it have the solder in it, it also had flux in it, and it would hold the part down. The problem that I have with solder paste is that it leaves a lot of little tiny solder balls, and of course they are conductive and cause problems, and they can be hard to clean, hard to remove, and I gave up with it. I just went to regular solder. So the first step is to heat up the one pad, put a little bit of solder on it. Just a tiny bit, you don't need a lot. Now you can see I'm already struggling with getting solder on the pad. And that's because these thin solders don't contain a lot of, there we go, they don't contain a lot of flux. And flux is your friend. Okay, so that's not bad. We're going to shimmy this over. And shimmy is a technical term. Let me get you up there on the bump. Now this is where, oh, I don't know why I'm having such a hard time with this. I didn't even have caffeine this morning. Okay, close enough. So now we can, of course you moved off it. And this is the struggle because there's no extra flux on the board. So to put this down, I use Amtech NC5559 V2TF, a big syringe of it, flux, and I put a little extra on the pads here, like this. And this will help tremendously. So not only does it help the solder flow, it helps the parts stay put. It's a little tacky. Okay, whoops. So now, carefully hold it on. Carefully hold it on. Okay, boy, 600. You know, I might have to change tips on this one. There we go. I'm not pushing down hard enough. There we go. Okay, so in the instructions, it'll say if you notice any corrosion on the legs of the chip, just to use an X-Acto knife and clean them off. I don't recommend that because X-Acto knives are very sharp. These leads are not very thick. They are, yeah, I see the problem with this. Let me, I'm going to change tips here. Hold on a second. This tip, I think I'd left it on from another project and I didn't check it before starting the stream, that I didn't have the right one on there. Where's my... Take a couple minutes here to get up the temperature. Okay. Little tinning. All right. Let's get back on this. Okay. Right tip helps tremendously. So the technique I'm showing is just tack soldering. You can take a wide, nice looking, and just like this. Okay, the other way to do it is to put, it's called drag soldering, is to put a whole bunch of solder on your tip, and then you just do this. Okay. And there you have it. That's all you need to do. You don't need a hot air rework station. Don't need a scope or anything like that. You can just do it this way. Okay. That's down. That's the hard part. Get the scope out of the way. Go back to my keyboard. And now we put in all the through-hole components. In we go. There we are. Okay. We got that taken care of. Let's take a look at our instructions, and here's the whole parts list. Board layout, where all the parts are going to go, and we're going to start with the instructions. Some kits don't have instructions. Some of the stuff that I work on, and in previous videos I've described how to build those types of projects, but this one has instructions, and we will use them, except the X-Acto knife part. This part here. It's a good way to nick one of the leads, and if it breaks off, then it can be fixed. There are techniques to fix that, but why risk it? The flux will handle any corrosion that's on there to begin with, so it should be easy to just put a decent amount down on the board and go from there. So we need to install D2 and D3, which are our two diodes here. Where's my... Oh, there we are. My little... And I sent it flying, of course. There's the other one. We'll have to find that one. So you have to be careful. You need to match the band. So there's a black band on the diode, and you want to match that to the silkscreen. If you put it, actually in this case it probably doesn't matter, but follow what's on the silkscreen. We'll get this built up. On the bottom of the board, I splay the ends out so it holds the component down on the board. Then, let me see if I can spot where that other diode flew to. I heard it hit the plastic. That's a great start there. Oh well, I'll just have to be careful. Okay. Yeah. All right. Well, that's what happens when you live stream things. These things happen. Let's get some of this out of the way here. Okay. So we got the diodes in. Install 5.1 microfarad caps that are marked 104. And that's all these little ones here. I think they're all 104s. Yeah, those are all 104s. That's the long one. I think that's the other .001. Yeah. Okay, so let's get those installed. C1's up here at the top. And I put my parts in so things are right reading, meaning resistor color codes are left to right. You can see the names of the components when you look at the board. In its correct orientation. All the markings, so that way when you're looking at the board you can read all the part numbers and things like that. So so 1, 2, C3 is up here. So 1, 2, 3, 4 is right here. Now you can't always install capacitors, so all the writing is to the left or from top to bottom, because some of the electrolytic capacitors are polarized and they can only go in one way, and it's usually marked on the board the correct way to insert them, and you have to follow those instructions. If you don't, you will get surprised and your project won't work. So get this flipped over. I always think I'm organized for these projects, but then when the camera starts to roll, so they say, things change. Get these soldered down. Hope everyone had a good 4th of July here. We did. My wife and I went out and enjoyed ourselves. On July 3rd, one of the local casinos has fireworks on the 3rd. So we like to go out there and beat the crowds on the 4th. No, I did not change my tip. I know what you're thinking. Why is he using that tip? Well, because it's already on. It's already in. Because it's already on the thing, and I don't need to change it. Give me some more solder here. Seem to be bumping the mic. Sorry about that. Okay. Now trim off the leads. Let's start this end. I don't think that's set down okay. Still, why is this loose? It's all one thing or another, isn't it? Live streaming. There is so much to learn about live streaming. You know, I've only been doing this, what, maybe 6 months? It needs a little more solder on it. And boy, is it a learning experience. It's not simply just putting up some webcams and going for it. It's there's a lot more to it. And I am going to change tips here again. That's just not going to cut it. Works great for this tip. Works great for surface mount, but it doesn't do much for through hole. So we will go back to we'll use that one. Yep. Switch to an 1/8 inch. I think I should have 2 soldering stations. But I'm quickly running out of running out of room here. Isn't life fun? I tell you. Computer problems and all that. All right. Okay, so we got all the cap zapiters in there. Who do we have next? C6 is the 0.001, and C6 is right there. It's a little tighter. Okay, there we go. That brings us to the end of the capacitors. All right. What's next? Okay. Hold on 1 second. All right, see if that's better. The mic stays in place. Okay, we got the capacitors done. So we have a R1 is a 10K resistor which they put very nice. They put the color code there for you. Brown, black, orange. Is that right? Yep. And gold. So this is R1. And R1 is... Where is R1 on this? R2's over here. R1's right there. So we'll get our little handy dandy little gauge here. You know, I like things to look nice. Have nice bends in the leads and all that. Just funny that way. Now to make these right reading, these are top to bottom. You can see the color code from top to bottom on the resistor. So what's 2? R2 is a 10. Brown, black, black. Brown, black, black. R2 is right next to it, and it looks to be the same. Yep. And this reads right, left, just like you're reading a book. R4. Oh, I'm sorry, R3. R3 is the blue, gray, red. Blue, gray, red, R3. This one is going to be the same. This one will be the same width as the body of the resistor. So we'll just bend it like so. Left to right. Do that left to right. And the second to last is R4 is red, red, gold, which is right here. And R4 is right there on the board. It's also the same width as the body. Red bands on the left. And R5 is green, brown, black, or by process of elimination. Process of elimination, it has to be this one, but always double check the color codes and your parts list prior to starting. Okay. Resistor's not down very well. Okay. All right, we're good. Let's get these soldered down. Didn't get a chance to participate in the 13 colonies this year. I'd wanted to, but I've got so much RFI now that I have to redo everything. What I had set up in the past isn't quite cutting it. And I'm planning on a full video on that one. It's one of the most popular videos I have on my YouTube channel is RFI and using noise cancelers and all this. So I am working on a a full-length video starting from nothing and going through adding chokes, cleaning power supplies, you know, everything on the rig, and then using other tools like the MFJ noise canceller, which I have very good luck with out here. Let's see what else. Using a receive-only loop, especially on the low bands, it makes a tremendous difference. But first, you want to get rid of the noise at it as much as possible before using those tools if you can. And we'll go over all that. Putting chokes on cables, resources. I'm still kind of working my way through that one. And that one's going to be edited. It would take too long to do. I don't like that joint right here. It would take too long to do as a live stream. So I will do it in segments and put it together as a regular video. I've not done that before either. So expect some surprises along the way. And let's see this. A little too much on there. Oh, did I miss one? I think I missed one. Let's get these out of the way. So I like to do assembly like this in batches. You know, I'll do a half a dozen or so resistors, then solder things down, trim things off, yada yada. I did not. Okay. We'll trim those off a little closer. That's better. Okay, so that gets down all the resistors. Let's see. Well, they're using a socket for the op amp. I'm mixed on that. I think these days a lot of electronics now are so robust that you don't really need one. But we will put this down anyways. So on the silk screen, pay attention to the little cutout so it matches. Let's see if this will work. So it matches. It's fuzzy, but you can tell there's a cutout right here. You want that to match. And it just slides in like so. And then using fingernail, kind of bend two of the corners over. And then keeping it on an angle like that. Keep it on an angle like that so you can tack solder it in there like that. Okay. And you can tack solder the opposite corner. See, it just popped out. Now it's in there, and you can use just solder the rest of the leads in there. Or pins, I should say. Double check that one. And that looks good. I moved it out of the way. Oh, there we go. Okay, so we've done that. So install Diode D1, which is right here. That's interesting. Okay. For a second there, it's kind of a little confusing because here's the transistor on one side and the silk screen is sort of like a transistor. But what they're doing is on the LED, there's a flat spot, which, very good question. I don't see one. Oh, I know what happened to those. It's right here. So, in the instructions, it'll say the long lead is positive and must match with the silk screen plus. So it's right here. Okay, we will solder that down. More solder. All right. Diode is in there. Okay. Let's see what we got now. Oh, I guess I bumped something. That wasn't a transistor. I'm sorry. I apologize. That was the voltage regulator. This part looks like a transistor. It's in that form, and it needs to go in there. So we take, and the middle lead needs to be bent back a bit. So take some, just a little bit. And pop it in. And you don't need to slam it all the way down on the board. Give it a little bit of clearance is fine. And then flip it over. And get all this solder in there. Yeah, I got a little bridge. Little bridge. Yeah. Always have some handy dandy. It's hot mark. Come on. Get in there. Solder braid. Oh, gosh, I can't do two things at once. Have some solder braid handy. The kind that I like is by Chemwick. This is what I use. Number 4. It also has rosin in it, dry rosin, so it makes it a lot easier to extract solder. And as it looks, that looks fine. We'll get these trimmed off. So that's our 5-volt regulator. If you remember the schematic that goes into the powers the op amp, and the AD8307 powers that right there. Okay. Solder all pins for this part. So we have the kind that has 2 center pins in it, and according to the instructions, we have to cut those off. All right. cut these off flush. Like so. Now you can tell it's missing. This goes vertical in the holder, or in the, like so. Now this is going to be a little more challenging to get soldered down because it's not going to stay. It's not going to stay put. So here's what we do. We're going to put a blob of solder on the center pin. Like so. Fill in the hole a little bit. We're going to put this in line, heat it back up, and shove it through. Like that. Okay, so now the center pin is soldered down, and it'll stay on the board and we can finish it. There's a lot of thermal mass on this part, so it might take a little longer to get soldered down if you stay with the same size tip. Don't worry about it, just you won't harm anything. All right, and then let's touch up the center pin. Okay. And there you have it. Okay, what's next? Install 9-volt positive battery clip. Okay, that's going to be these parts here, and it's going to be the same issue with these. Maybe not. Maybe I can just bend one. No, they're too tight. Okay. Now these are going to take some heat. Let's see. Let's do the same technique, but this time we're going to use some fatter solder. And we will do this from the top. Set it sort of in the hole, reflow the solder and shove it in. Okay. Yeah, that's not going to work. All right, that approach is not going to work. Let's get the solder out of it. All right. Okay. Let's get the hole cleaned out. That's not going to work. I might have to change a tip again to do this project. going to change tips for a third time on this. Need something with more thermal mass. And does that mean how much the heat weighs? No. It means how much heat can be stored. So the negative lead of this 9-volt battery also goes to, it's on both sides of the board. You can see the flooded ground plane, and all this copper acts like a huge heat sink. Plus you have the component itself, the part being, I'm guessing it's tinned copper, and it's also a large chunk of metal. So you're going to need a fairly beefy tip, and I cranked up waiting for my soldering station to get caught up here on high, and we will give this a go here in a minute. Let's okay. Okay, it's ready. Pulled out the 1/4 inch. All right, hold on. Tighten up. Sideways. All right, there we go. Bigger tip helps a lot. And that, folks, is thermal mass, where the iron can store enough heat in order to heat the joint up with all that copper around it and all the other metal of this one. So we're going to use the same technique here. For the positive, tilt it up on its edge, and reflow it, push it in, and that's it. Now we can solder all of it back together. Finish soldering the leads here. Okay. I missed one right here. All right. That's where the 9-volt battery goes. Okay, what's next? Next is the switch and the tactile switch. So the, not that one, this one. Gosh. Which way does it go in? Doesn't matter. So let's think about this for a second. It doesn't matter, I guess. Depending on which, well, okay, look at the screen. Silk screen says on off. So the switch in that direction. These two pins are shorted. I don't know where that goes. Okay, that goes from 9 volts. You can see on the board. Oops. 9 volts to here. Switches on. Carries the 9 volts into the regulator. Okay. So this is on. And we can solder that pretty good from the, we'll start by soldering it from the top, just to tack it in there. You need another large tip on this because you've got the metal case of the switch and the copper below it. So now we can finish. Gotta let it cool first. All right. There you are. Solder sucker. Gotta clean the holes out now. All right. Oh, that center switch got full too. Hold on. Or this pin on the switch. Okay. Let's put it back in. And yes, it doesn't matter what side the switch goes in where. I was right the first time. Let's solder it from the top again. Was that crooked? No. All right. Yes, I need to get my fume extractor working. Okay, there's that switch. All right, that switch is in. Now we need to put S2 in. And you notice this part is not square. The pins are closer together on one side than the other. And you just slap that in. That'll stay up on its own. Got this huge fat tip now. I'm not going to change tips again. Come on. And I would trim those off. They're a tad long. Okay. Oh, what's next? So we got that done. The momentary on-off switch and the regular power switch. Be careful with this one. It does require extra heat due to the metal case, but it'd be very easy to melt the plastic switch part. So just be aware of it. What's next? It's necessary about the voltmeter to read the voltage of the LM358. So we'll be modifying 100 lower voltages, but retain the 0 to 99.9 scale. This is done by bypassing the scaling resistors. Okay, let's move this out of the way. Here's the voltmeter. And we have one of two kinds. Okay, so let's see what kind we have here. Do we have the first kind or the second kind? There's a resistor here. Remove it. Okay. I don't see one. Nearby. So they want us to jumper to there. Okay. Like so. No, we have the first one. So okay. So we have this one. In order to do this, we have to switch back to the scope. I'm not sure how well the visor would work with this. You know, the magnifying visor. So let's flip to the scope. Let's get it looked at here. Okay. So what the... Get you in focus here. Okay. So what we need to do then... Okay. So this pad, where's my pointer? So this pad's already empty. What the instructions want us to do is make a jumper from here to here. Here to here. And they gave us a little piece of wire wrap wire. I have a slightly different way of using different. It's using different wire. So what I'd recommend you do in this case is use some to use some 34 gauge. I buy this, obviously by the roll here, and that's how I do repairs on surface mount projects. You know, if I lift inadvertently, a pad's lifted or whatever, I use little wire jumpers like this. They can easily be soldered down and then soldered across, and make those repairs. If you have, you know, also like a repair of a broken trace somewhere. And that's what I do. I don't know the I think the wire wrap's going to get a little messy. So now I've got to hold this down. Let me get this kind of cleaned up over here. I got some solder down here. Okay. So now we're going to take this bad boy. All right. The wires are going to be a pain in the butt. And gonna have another tip change. Am I? Yeah, I'm gonna have another tip change. Okay, let's I gotta figure out how I'm gonna hold that still. Okay, some clamping tweezers here. Might hold it still enough. But my camera focus is off. Wow. Looks fine in them. Yeah, there we are. Okay. We're going to tape that down. Not on that one. Hold on one second here. Duct tape. Keep a roll handy. Tape it down right there. All right. That should work. Okay, so now we need to jumper from here to there. I need another piece. I didn't make it long enough. And I gotta change tips. What's going on here? There it is. Barrel didn't want to come off. Put that back in the holder. All right, that's the one. Back to my knife edge. And I gotta turn the temperature down. I don't need this all the way open. Okay, so now I'm going to put it right there to start with. Now this is enameled wire, so I don't need to worry about it shorting out anywhere along the way. So we're just going to solder it down to that pad and then work its way over to here. Turn it down to about 650 degrees, because if you don't, sometimes you can lift the pad, and I don't want to do that. Start off with our favorite flux. And it's going on right there. And let's see. Oh, I gotta hold this. How long have we been going for today? Hour 26. We're getting there. And well, that disappeared quickly. Okay, we need a little more of a lead on that one. Okay. So now we're just gonna get the tweezers to hold on to this thing. I think my tweezers are bent. I think time for a new one. Yep, reflowed that couple of pins on that. All right, come on. Soldered it through. Okay. Almost. Here we go. And now we'll route it around. Like so. Tip looks huge under the scope. That's for sure. Can I get in there? And lay down. Ah, there you go. Good job. All right, got to put the resistor back. Okay. There we go. Okay. Well, that was a surprise. Yeah, we'll just... Okay, so this is pretty tricky, actually. There we go. That's a better looking joint. Not the kind you smoke, of course. This is California after all. We'll tidy that up. And then we'll take the tweezers here. And there we go. We've got it jumpered. So that was not bad, but still, it's going to take some effort to do this right. And I'm using a scope. So kind of reroute it there a little bit better. There we go. Okay, so that part's done. Let's go back here. Happy supply 30 wire gauge. You don't have to short out any other components or remove a resistor. Okay, so we got that part done. All right, so now prepare the wires for the digital voltmeter by cutting them 1/2 inch long. Okay. Oh, my lighting's not that great. Half an inch long, huh? We can do that. It looks like we're not leaving the insulation on, so we'll give them a little twist. And then make sure everything stays together. Don't pull too hard, you might rip it out. I didn't twist. Well, they want to just tin them. Like so. Feed the wires through the PCB pads 0.123 and mount the digital voltmeter using the 256 hardware, which we have right here. All right. Like that. You know, I'm gonna pull it out of here for now. Get our hardware. Just set it down on the mat like that, and then we will kind of bend them so they go in the hole. A little bit of that tape I used earlier, we'll use that to hold the screws in, down. And I inadvertently covered the holes in the circuit board. So we'll leave them open like that. Put it through in order. All right, we're not doing it that way. Screws down. Shown in, yeah, well, if you show in the figure below, scroll down. It's a snug fit. Just drop the other side out. Okay. Hold on here. So it's a really snug fit next to that IC, but just carefully push it down. There's the other nylon spacer. It fits just fine. Tilt it up. All right. And put on the little... All right, let's do this. We will tighten the other side down, bringing the voltmeter closer to... oh, come on. Phillips. Gosh, it's always the last screwdriver you find, huh? Let's see if that helps push that screw down a little further. All right. We got the, you can see in there, got the 3 wires in the appropriate locations, so we need to solder that down. I'm refusing to change tips again. Come on. There we go. The whole thermal mass thing. That one. A little more on that one. Okay. Okay. What's next? Before installing the install be this bad boy. See if it touches the resistor lead of R2, which is that one, which that was for the metal one, the metal B and C. Okay, gotta straighten out the pins a little bit. Because you want to get the 2. And this sets down real nice. And you just need to make sure inside here there's these two little wires are through the circuit board, and then they didn't accidentally get mashed underneath. And you'll know because you won't see them on the other side, but also because this won't sit flush on the board like it should. So now I'm going to have another thermal mass issue, and I'm refusing to change tips again. So what we'll do is give it a big blob of solder. Give it a few seconds here. Yeah, that looks good. Okay. See how that didn't get down there. You see how it made a bubble, a ball? Okay. And then don't forget the leads on the connector. Okay. I think we're running out of parts, except for D2. I gotta find D2. Okay. All right, let's see what we got now. Install R6, the vertical pot right here. This won't be so much of a problem because it's just plated through hole. It's not going to, see it's crooked, so you want to be careful with this. Okay, now we just got to put these down. Okay. Nice and smooth. All right, got to put in the LM358. Now, when you get chips like this, you'll see that their legs are flared out like this. And they don't quite fit. You can see it's not quite fitting in the socket. So what I like to do is just take it and bend them in just a little bit. Now we got to look for the notch. And then the notch is right here on the top. This is pin 1. Okay. And it should just slide right on in, just like that. So when you're installing this, you can see the notch matches the notch on the socket and the notch on the silk screen. Okay, so be careful. Don't put it in backwards. And except for the missing diode, I think that's it. Install alkaline 9-volt battery. I don't have a 9-volt battery, but I do have a digital power supply. So it will feed at 9 volts. Make sure the switch is off. It's set for 9 volts. Channel 1. But before I apply power, I want to do a quick continuity check here. I always do this on my projects just to make sure I didn't accidentally short something out. Oh, it's not beeping. Oh, it's capacitance mode. I missed one here. Got a new. There we are. I got a new voltmeter here. You know, I don't think I need you anymore. Got a new voltmeter, and actually it worked. It has a cable to connect to the computer so you can see it. And I had it working up here in the upper left corner, but some reason this morning didn't work. So let's take a quick check here. Make sure I don't have any shorts. And we're good on that. Okay. So we're good on that. Got 9 volts on the digital voltmeter. All right, power on. Ooh. Well, it's picking up something. So the sensitivity, boy, this is really, I don't even have an antenna on this thing. And it's probably picking up, if I remember the data sheet for the logarithmic amplifier, it's rather sensitive, so it's probably picking up my overhead lights. But why is it working with the missing diode? Well, if you remember in the schematic, these are clamping diodes used in case something goes over voltage. I'm just obviously I'm not transmitting next to it or anything. So I'm not worried about ruining the front of the chip. I'll have to go find that diode that went flying, which is very common in when you're building things. Let's see, so off, I turned it off, and it does the spot check. Hey, that's pretty slick. And then you can see the diode coming on, the LEDs coming on. So I would call this successful. I really would. So thanks, QRP guys. This was fun. Got to put the feet on the bottom. That's all that's left. Find a 9-volt battery, and you got yourself a piece of a little bit of test gear here to see if your transmitter is transmitting. I actually have a field strength meter I use in my shack just to make sure I'm actually putting RF out. It's okay to have all the meters and things, but sometimes they lie. You're putting out power. Your antenna tuner has tuned something, and come to find out, you're on a 3-foot antenna inside your house, and you're not really going anywhere. And why is my field strength so low? Oh, I took the power off. All right, so there you have it. It's QRPGuys digital field strength meter. A couple of things I noticed while building this is the pads could be larger. There's plenty of real estate on the board to make them a little larger, I think. It would have made the soldering a lot easier, I think. Let's see, what else can I think of? That was the big one while I was doing this. Of course, working with the voltmeter, that's the tricky part. To be careful not to overheat. I think it's a 0403 part. It's pretty tiny. You can put the red LED filter over it if you wish. See how that looks. I wonder if it looks better with it on. Huh. Yeah, it does actually. Yeah, it really it hides the segments that are turned off. Where here you can see them. Huh. So yeah, figure out a way to put this down. You can even put it in a case if you wish. So I think there you have it. Yeah, the only comments I have is making the pads larger. I think that would have made assembly a little easier. And dealing with the voltmeter, that's tricky. That's going to be the hardest part of the project, I think, is changing that around. They did provide the wire to do so. I don't have it hand. I don't know what I do with it. So you could use that. Just be careful that that wire is for wire wrap, and the insulation really isn't designed for a lot of heat, so it's probably going to melt pretty quickly. So just be careful of that. So that's it. Got my closing notes. I hope you enjoyed it. Once again, I apologize for the start of this. Really, I get ready the night before and had it all ready, and I think I should have just left everything on so I didn't have to mess with it first thing in the morning here. Double check the YouTube streaming key, and I don't know why that changes, but apparently it does. Let's see, what else do I got going on? So I hope you liked what you saw. Please subscribe down below. I'm trying to get to 100 subscribers so I can create a custom YouTube channel. You can find me everywhere. You can find me on, of course, my website, ka6wke.net /live-stream. I'm on Twitter as well, ka6wke. I'm on Facebook, same thing, same call. I'm also on Instagram now. So that's interesting, bench_therapy. And I will put in the description below, I'll have the equipment I used, the links to the data sheets, links to the QRPGuys website. And from that, I will see you next month. And I hope you build something. Stream at you later. Bye.